Diode test. To test a diode, first set the meter to ohms. Then press the select button once. You'll see the ohm symbol, or omega, disappear, and the diode symbol will appear. The meter will now test the function of a diode and will give a reading in volts. If the diode is functioning properly, the meter will show approximately 1/2 volt, or 500 millivolts in forward bias, and OL in reverse bias. If these two readings are not seen when the diode is flipped and tested in both directions, the diode is likely defective.
The diode test is actually pretty useful. The diode test is the meter sending voltage out exactly the same way that it sends it out for ohms. However, when it comes back in, it's interpreted and calibrated in volts. Diodes read in approximately 1/2 volt in forward bias when the diode is functioning, and in the reverse bias position with the leads reversed, the meter should read OL. Diodes are used as electrical check valves for two fundamental reasons in the transportation industry. One, they're used for arc suppression across coils. The diode will suppress the arc caused by the collapsing magnetic field in the coil when we turn the coil off. This is true of solenoids, it's true of motors, and in some cases relays and larger relay solenoids. So the diode in that situation would be used specifically to cause the collapsing magnetic field to fade into harmlessness instead of surging out and back to the switch, causing the switch to arc. The other use of diodes is for directional control and switch configurations. So it's possible to make certain switches turn on certain things and other switches turn on other things. And we can do this very simply by using diodes in the circuits to allow current to flow in one direction but not another. Diodes are very often referred to as electrical check valves, and that is in fact what they are. But they don't measure in ohms, and you shouldn't try to measure a diode in ohms. You should always try to measure on diode test. To test the diode, you simply hook the meter up in one direction or the other, and if you see 1/2 volt or approximately 1/2 volt, then that's what's referred to as forward bias. Forward bias means the connections to the meter and the connections to the diode are the same, plus, plus, minus, minus. This is how you install it in the circuit in order to make current flow. If you flip the leads or you flip the diode, you should see OL, meaning that it's blocking. In reverse bias, an OL reading is correct. So a correctly functioning diode should be showing about 1/2 volt in one direction called forward bias, and it should be showing OL or no continuity through the other direction, which is called reverse bias. Diodes must be removed from the circuit to test. They have to be isolated and they have to be removed. In some cases, it might be necessary to cut the end off of one terminal, lift the diode up and test it. In which case you might want to just, you may either replace it or you might push it back down and resolder it. It's entirely up to you. But I will say this about diodes, and I caution you to listen carefully. If you know there are diodes in the system that you're testing and you're suspecting that they might be failed, do not do anything to the machine until you confirm the correct operation of every diode that might be involved. If you don't, you're going to be sorry. Diodes fail simply and people overlook them. A shorted diode will make a machine look haunted. An open diode is just an open circuit. But an open or shorted diode across a coil will either cause the fuse to blow, the short, or it will cause the switch to fail because the suppression is no longer taking place. So the two functions of a diode typically are arc suppression for coils and directional control for switching in systems with multiple switches and components. Make sure you remove the diode from the circuit to test it, and make sure that you do not fail to test it in both directions. OL in both directions is open. 0 or some number like 0 or close to 0 in both directions is shorted. 1/2 volt in one direction, forward bias, and OL in the other direction, Reverse bias means the diode is actually good. Small note. Additionally, however, you cannot use the diode test function to test LED lights. They won't, it just will not work, okay? Don't try it. If you're going to test an LED, and I strongly advise you to do this before you throw them in the trash because they're very expensive, you simply pigtail the LED and hook it to a battery. It works or it doesn't, okay? The meter on diode check is a very poor choice for testing LEDs because in my experience, it does not work. Diode check. Diodes are technically electrical check valves. The banded side, let me bring it up here. Okay, the banded side is the negative side. Okay. This other side over here, that's the anode, that's the positive. So it's negative cathode, anode, cathode, anode. So you test diodes by going to diode check, as you see. And then if you have the meter in the correct polarity, you read about half a volt. Now that's reading in volts. Hopefully I can zoom in on that, but you should see in the bottom right corner the letter V. Okay? If I flip the leads around, if the diode's working properly, I should get OL. Okay? Meaning the diode's open in that direction. Do not use the ohm meter. That's the old style of doing it with the needle. There is no needle here, so use the diode check function. And always check diodes with them out of the circuit. Do not check diodes in the circuit. That does not work. Okay? That's the same as ohming something out without isolating the circuit. So diode check works by measuring the pressure that it takes to turn the diode on. If you see 0 in both directions, it's shorted. If you see OL in both directions, it's open. And what you're looking for is about half a volt. Okay?